Hello class, this is Mrs. Tanga. I was waiting for individuals to come for the review, but nobody came. So what I'm going to do right now is we're just going to go and review a couple of things, specifically the calculations for this review. Not much on the conceptual part. Okay, so make sure you still study that. All right, the first thing we're going to look at is matter. I just want to make sure everybody understands what matter is. So matter is anything that occupies space, all right? And matter also has mass. So if something is occupying space and it has a mass, we consider that as matter. That is matter. All right, even if you see it, whether you don't see it, as long as it occupies space and it has mass, that will be considered matter. All right. Now, let's see here as we so make sure just review everything, please. Make sure. So the one thing that I'm gonna look at is the law of conservation of mass. So for this particular concept, always remember that the mass of your reactants is the same as the mass of your product. So what we're gonna do is we're gonna make sure that you understand that both sides should be equal. So for example, if I have two squares, all right, 2 grams of squares, and then we add 3 grams of circles. If you add them, it will be equal to 5 grams of squares and circles. So as you can see, nothing disappeared, nothing left the system. So this is what we call law of conservation of mass, all right? So in this case, always remember that your mass, the amount of reactants or the mass of your reactants will always be the same as the mass of the product. This is very important for chemical reactions because when you have a chemical reaction, matter is the one that's transformed. It's just changing. So you're not destroying matter. You are also not creating new matter. Okay, so all you're going to be doing when you have a chemical reaction, as stated here, is that matter is only transformed. So we put together two things. In the end, we are changing them. We're not creating them. We're not destroying them. We are changing or transforming them. All right, so here's the formula you can use. Mass of the reactant plus the mass of the other reactant should be equal to the mass of your product. So in your handout, there are a couple of questions regarding this. So this is the formula you are going to be using. Okay, all right. So let's see here. Let's check and see if let's try this one actually. Let me go into another page. Let's see. I think I'm going to do a little bit of practice on this one. Okay, so if you look at your handout, you'll see it there. So we have sodium and chlorine. If you add them, you will produce a salt. So first problem on the law of conservation of mass, it states that I have 39 grams of chlorine and 25 grams of sodium. Because this follows, because it's a law, the law of conservation of mass states that you just add the reactants to get the same amount of salt. So if they're 25 and 39, if you add them, you'll get 64 grams of salt. As you can see, all the sodium and the chlorine just became salt, so that means they transformed or they changed. They didn't really get destroyed, and they were not, nothing new was created. Now let's change this a little bit. Let's say same reaction. Let's say I have 39 grams of chlorine, and let's say at the end I produce 100 grams of salt. So the question now is, how much sodium do I have? You probably know how to answer this question, but if not, we can actually use a simple algebraic we can write a simple algebraic equation on this. We can set sodium as an x, so x plus 39 is equals to 100. If I want to find x, all you need to do is move that 39 to the other side, so 100 minus 39, your answer will be 61. So let me write that down. Okay, 61 grams of of sodium. So as you can see, the amount of the sodium and the chlorine, they should stay stable and produce the same amount, at least gram-wise or mass-wise, of salt. Okay? All right. Let's compare elements and compounds. So elements and compounds are both pure substances. So I want to make sure everybody understands that. So what we mean by that is element by its own. If I get an element, it's a pure substance. If I have a specific type of compound like salt, it's also a pure substance. So let's go and differentiate the two because we need to make sure we know how. So an element is very specific, and there's 118 that is known to man, and you will find those elements in the periodic table. Okay, so for example, oxygen, hydrogen, sodium. Okay, so all of those by itself is an element, and they're pure substance. Compound, on the other hand, it is a combination of two or more elements. Okay, regardless of whether the elements are different or if the elements are the same, as long as you have two or more elements, we consider that as a compound. So, for example, let me see here. H2. So that's two hydrogens attached to each other. This is still a compound even if it's made out of two same elements. Okay? Water is a combination of hydrogen and oxygen, so that is a compound as well. Same thing with salt, NaCl. All right? That's a combination of sodium and chlorine. So you can see that's a compound because it's a combination of two or more elements. All right? Now, when you're writing it down, remember that the element, when you're writing elements, capital letter first, and then if you have a second letter, make sure the second letter is a lowercase letter. So please make sure you do that, because if you put them all both lowercase or both capital letters, then I'm not going to count that, because it's, we have rules on how to write an element. Okay? All right. Let's move. Okay, so here let's look at molar mass. So when we look at molar mass, we are literally looking at the total masses of your substance. Okay, so when we have a molar mass, we would use the periodic table. So let's use sodium as an example. So make sure that you have your periodic table available. So the first thing you need to do is put sodium, or put the elements and separate them. So I have sodium and I have chlorine. Next thing you need to do is go to your periodic table and find the atomic mass of sodium. So if you look at the periodic table, the atomic mass of sodium is 22.990 and chlorine is 35.45. Since we only have one sodium and one chlorine in sodium chloride, we don't have to do anything, and then we just add them. That gives you 58.44, okay? And that would be the amount or the molar mass of sodium chloride. So when you're looking for a molar mass, make sure that you are looking at your periodic table. Let's try another one. This is also on your handout. Let's try glucose. Glucose is C6H12O6. So first thing I need you to do is write down your elements. I have carbon, I have hydrogen, and I have oxygen. And let's write how many of each we have, because that will affect your molar mass. I have 6 carbons, I got 12 hydrogens, and 6 oxygens. Okay? Now, so the next thing we do is we look at the periodic table and find their masses. So let's look at carbon. Carbon in the periodic table states that it's 12.01. I think that's right. Hydrogen is 1.008, and oxygen is 15.999. Okay? So you see those numbers 6, 12, and 6. All you need to do is you multiply the atomic mass by the amount. So 12.01, if you multiply that by 6, it will give you 72.06 grams. Same thing with hydrogen. I know hydrogen is 1.008. Multiply that by 12. That will give you, wait for it, 12.096 grams of hydrogen. And then we get to oxygen. Oxygen is 15.999, but there's 6 of them. So if we multiply that, let's see here. Okay, it's going to be 95.994 grams of oxygen. Now that we got those numbers, we just add them all and we will get the molar mass. And the molar mass of glucose is 180.15 grams of glucose. So that is the molar mass of glucose. So make sure you follow those instructions to make sure that you have and you can get all the numbers that you need. All right. Okay, let's move on and let's look at the law of definite proportions. So according to this law of definite proportions, the percentage by mass of each element in a substance is going to be the same regardless of the amount of substance. Okay? So, for example, which example should I use? Oh, water. If I have 1 gram of water versus 5,000 grams of water, the percentage of hydrogen and oxygen in that water is going to be the same. Okay, so the way we know if two substances are the same is we look at their percent mass. If the percent masses are the same, that means they are following the law of definite proportions and they're exactly the same. So let's use the problems that we have on our handout. I'm looking at sodium chloride. If your problem does not give you any number, so for example, that first problem on the law of definite proportions, it doesn't give you any number, I can still find the percentage of sodium and chlorine in sodium chloride by using the periodic table. So to do that, I'm going to write my elements. It's like finding the molar mass. Okay, let's write for sodium. We know it's 22.990 grams. Chlorine is 35.45. So all we need to do for the first step is to go and find the total mass. Okay, so if I add this two, it's going to give me 58.44 grams. Okay, so this is how much sodium chloride I have. So the next thing I want to know is how much sodium by percent do we have in sodium chloride and how much is chlorine. So here, I'm going to write the mass of sodium by itself and divide it by the molar mass. Okay, and then we multiply that by 100. Whatever number you get, that's the percentage of sodium in sodium chloride. So if I calculate that, that will give me, hold on, 39.34%. So roughly about 39% of sodium. So in sodium chloride, the percentage of sodium is about 39%. Now let's try chlorine. So again, write the mass of chlorine and then divide that by the molar mass. Okay. And then you multiply that by 100 and let's see how much we get. It's, hold on. It is 60.66%. So roughly about 61%. So even if you have 1,000 grams of salt or 1 gram of salt, the percentage of sodium and percentage of chlorine stays the same. That's why we call it the law of definite proportions. All right. Now, that's a situation where you are not given any amount. Okay, so I literally just gave you sodium chloride and then you use the periodic table from there. Now, the situation's pretty much the same when you are given a problem where the amount of substances is already stated. Okay, so let's look at the second problem. So in that problem, we are given two compounds. What we're going to do is we're going to compare the two compounds. If the percentages are the same, that means they're the same compound. So let's look at compound 1. We're all still working with sodium chloride. So I know based on my data, I have 25 grams of sodium and I have 39 grams of chlorine. So to start this off, the first thing you need to do is you need to add those two numbers. Okay, because we need to divide the amount of sodium by the amount of the whole thing. So if I add this, this is going to give you 64 grams of sodium chloride. So the next thing we need to do is let's see here. Let us go and try and find, let's find the percentage of sodium. So we're going to put 25 because that's how much sodium we have, and divided by 64, and then multiply it by 100. If I solve that, that's going to give me about 39%. That means sodium, 39% of sodium chloride is sodium. Do the same thing for chlorine. That's 39 divided by 64 by 100. That will give you about 61%. Okay, there we go. So as you can see, these numbers are pretty close to each other, okay? See how on the problem above, we know that sodium in sodium chloride is 39.34%, which is roughly the same as 39. And then chlorine is 60.66, which is about 61%. Because they're the same substance, they're the same salt. The percentages of them is the same. The percentage of sodium and the percentage of chlorine would be the same for both. All right? So I just wanted to point that out. I know that previous problem is not part of the example, but I just want to make sure you understand what we mean by them being the same. Okay? So let's try compound 2. So we have compound 2. Let's try and figure out, is compound 2 the same as compound 1? If the percentages are the same, they are the same. If they're not, then it's different. So let's write the given. I got 15 grams of sodium and 23.5 grams of chlorine. Let's find the molar mass. That's going to be 38 grams of salt. Now, once you find the mass of your substance, let's move on. All right. Let's move on and let's look at the percentage of sodium and chlorine in this particular substance. Okay. All right. So percentage of Na. Let's put let's put 23.5 divided by 38. That's wrong. It's sodium. Okay. Why did I even write 61 when I know it's wrong? It's sodium. Right now what I calculated is chlorine, but I'm looking for the percentage of sodium, not chlorine. So let's go and erase that and put amount of sodium, which is 15 grams. Divide by 38.5, multiply by 100. That gives me about 39%. Okay, 39% of sodium. So as you can see, it's 39% Na on the top and then the bottom as well. So the percentage of chlorine, so that's 23.5 divided by 38.5 multiplied by 100. That's about 61. Let me just confirm. Yep, it's 61%. See, you have the same amount of sodium and the same amount of chlorine. What that means is they're the same substance. So this is what we call the law of conservation of mass. That regardless of how much you have, the percentage by mass is going to be the same. All right. Finally, let's go and look at the law of multiple proportions. All right, let's look at the law of multiple proportions because that one, it might be a little confusing, but if we follow the steps, then you should be fine. That's also why I tell you to write your notes, because by writing your notes, you are able to visualize what we're doing, and it will help you on your test because you can just literally follow the rules. All right, let's go into the law of multiple proportions. So if you have two substances and they have the same elements, but the They have the same elements, but the amount is different. We can see and use the law of definite proportions to figure out if they're the same substance or not. So let's try those two problems on your handout. So I have compound 1. I got 12 grams of carbon and 2 grams of hydrogen. So to start off, I need to find my percentages. If it's the same, then that means I don't have to answer the last question. If they're different, then obviously I have to figure it out to explain why the percentages are not the same. So this is compound 1. So I've got, first thing you need to do is add, well, do we add them? Nope, I don't think we added them. All right. So we just need to divide them. Okay. So I actually didn't have to add that. So I actually just have to, okay, yep, I forgot I was doing the law of definite proportions. All right, so based on these calculations, I look for the molar mass or the total mass of the two substances. Based on my calculations, I found that carbon is in compound 1, 85.7% of it is carbon and 14.3 of it is hydrogen. All right. So let's try compound 2. If compound 2 gives us the same percentages, that means we're done. That means we have proven that they're the same substance. Okay. So let's try compound 2. Okay. All right. Hold on. My pen's not working. Sorry. I thank you for your patience. All right. Ooh, why is that? I think I might have to charge it. Okay, it works. So I got compound 2. So compound 2 has 12 grams of carbon and 4 grams of hydrogen. So you can see, you can probably already make a conclusion that whether those substances are the same or not. So let's go and add that. So 12 plus 4 is 16. Okay. All right. So by looking at this, we can already know, oh, something is off. All right. How come one has more sodium and more carbon or more hydrogen? So as you can see, for the second compound, 75% of the substance is carbon and 25% of the substance is hydrogen. We can look into this data and we can already make how would you say it? We can make a conclusion that these two compounds are not the same. Okay? What do we do when they're not the same then? So that's another question. So if they're not the same, that means they're not following the law of definite proportions. However, there is another law that you guys need to know, and that would be the law of multiple proportions. All right, so let's look at the law of multiple proportions. Okay, let me just get this ready. My pen is acting up, but that's okay. I have patience. All right, so we're gonna use the same data on your let's use the same data to prove whether these two substances, though they are different, they still follow the law of multiple proportions. So to do that, we are going to find the ratio between carbon and hydrogen. Okay, so we're going to look at the distribution of carbon and hydrogen in the substance. All right, in this particular compound. All right. So again, the ones I just showed you is the law of definite proportions. So the law of multiple proportions in this case, it's going to be a little bit different because we are going to divide the two to find the ratio. So compound 1, what I'm going to do is I'm going to put 12 grams over 2 grams. Okay, so 12 grams of carbon over 2 grams of hydrogen. By doing this, we find a ratio of 6 to 1. So that means for every single carbon in compound 1, there are 6 carbons. Okay, so for every single hydrogen you have in compound 1, that is also equal to 6 of the carbon. So let's try compound 2. So that's going to be 12 divided by 4. Okay. So you can see the numbers are getting bigger. So what is it? So let's look at 12 and 4. So let's go and divide and find the ratio. So 12 over 4, that means you have, for every 3 carbons, you have 1 hydrogen. So as you can see, those are your ratios. So what do we do now? We continue that and assume that the 1 is not there. And let's divide the other numbers that are non-zero. Okay? So if you look here, it's going to be 6 over 3. All right, my pen's acting up again. Hold on. So if I have 6 carbons over my 3 carbons, okay, as you can see, you can divide them and you can figure out if they follow the law of multiple proportions. So now, if you look at the number I got, is it a 2? It's a 2. So it's a whole number. It's a whole number. What's the word? It's a whole number ratio, which means that the amount of carbon in compound 1 is twice as much as that of carbon 2. So by doing this, we can predict whether they are following the law of multiple proportions or not. All right? So I hope you understand that. So we only use the law of multiple proportions if we are certain that the substances we're looking at are not the same. Because if they're the same, then that means, it's already a definite proportion. So for substances that have the same elements but different structures, then we would put that into the law of multiple proportions. All right. So I hope you understood our the review today. I tried to get as much information as I can, and I hope that you are going to be ready for tomorrow's class. All right, for tomorrow's test. So anyway, that's about it. Sorry, I just went back in there. I'll see you guys tomorrow. Make sure to study up. All right, God bless. Bye.